Well, good morning, everybody. Today we're going to talk about stacks and queues. We're going to learn about, the differences other than the spelling. I can never spell that queue. By the end of this topic, we're going to get in-depth knowledge of stacks and queues. We'll explain a little bit of the big notations for these things. We're also going to have an example of how to implement stacks and queues. And also as a bonus feature, we're gonna know a little bit of the basic of how JavaScript works. So stacks and queues, what are they? They're both are linear data structures. They also allow us to traverse sequentially, meaning we can get the data one by one. And like I said, it's only gonna be, you can access the element only one data at a time. And unlike array, there's no random access application for stacks and queues. And they're both implemented in similar ways. So how are they different? Stacks is going to be first in, first out. The first item first in, last out, sorry. And then the queues is gonna be first in, first out. So we're going to look at examples of what they are in the next slide. So we have that. We talked about that a minute ago. The difference is that how items are, getting removed. The first in, first out concept and the last in, last out concept. So from the GA module, this is what it looks like. And so with the stacks and queues, the methods or the operation of this one is really very straightforward, unlike arrays. Like for example, if we need to get the first element, then we know exactly where to go. And then if we need to get the last element or the top of the queue, then we know exactly where to go. And so this is kind of like higher level of data structure. And like I said, we can control the operations because we know exactly where we need to access the information. Therefore, it's a little bit more efficient. So uses of it is that the stacks, if you want to access the last value that you've seen, Stack Overflow, if you've heard of that, that's like our developer go-to, I guess. And then it's also being used in the JavaScript behind the scene, which we're going to talk about later in the bonus. And also it's in the browser history. If you want to know the last, like when you click the back button, that's where the stack is being used as well. And function within a function, we will talk about that in the next few slides as well. So the operation of the stack is that, it's going to be O1 pushing. It's just very straightforward like that. And then popping, you just pop the last element. And then picking is just looking exactly where the element is. So that's O1 for all. The lookup, it's going to be ON, but that's going to be the worst case scenario, ON. So best case scenario for the lookup is if it's like the first element in the array or in the stack, then that's O1. The queues uses, queue is opposite of stack. And one of the uses of it is in the printer. So like if we were to queue something on the printer, whichever you put in first is gonna go first. And how about when you actually request for Uber? So when you request for Uber, if you're the first one to request, you should get a ride first. And the magic show, if you're on a wait list for some tickets that you really, really want, then if you're first in line, then you're gonna get that served first. So like the sister stacks, the lookup is also O1. Oh no, sorry. The other operations are O1 and the lookup is also ON. NQ is kind of like the push and the DQ is the pop. So they just, I guess, name it that way. So there will be differentiation in the operations. Okay, so in the implementation, pretty much we can implement the stacks and queues in the array and also in the linked list. So in array, if we know to implement in an array has the ability to cache in memory, so it will have faster lookup because all the data are right next to each other. The only issue with that is like, if the arrays get filled, then you're gonna need to build another array which has a double memory. So that's gonna be something we need to, I guess, think about if we're wanting to implement stacks in an array. And then, of course, in the linked list, as we know, they're gonna be scattered in memory. The only downside is that in every linked list, you're gonna need to have an extra memory for the pointer. And of course, memory is dynamic because you can just point to whatever available memory we have. For queues, array, you don't want to build, typically you don't really want to build this in an array. And this, do you know why? Does anybody know why we wouldn't want to? Let's see. So the reason why we don't want to put that into the array is because, for example, in the queue, if we have David, Crystal, Alana, and Robin, and we were to delete something from the front. So when we delete David, now this is gonna be empty in memory. So now we have to actually shift everything into David's last place. So I don't know if that makes sense for everybody, the way I'm saying it. But in the array, there's gonna be, you're gonna have to shift everything into the place of, like, Crystal's gonna go to 0, Lana's gonna go to 1, and Robin's gonna go to 3. So that's why they're saying that the implementation of queue in the array is not very, very efficient. Next is that on the linked list, the access for that is 1, and then let's see why. Okay. I already have that right there. Okay, since JavaScript doesn't really have a built-in stacks and queues, we can actually implement it by creating our own stack and queues. So the first thing we can do is actually create a node for the element. And then in our stack, there's always gonna be the top and then the bottom. And then just for fun, we can do length. So now if we were to pick at the, to do the pick operation for this, then that's very simple, right? We just need to know which one is the top, because pick is going to look at the very last item that was put into the array or into the link, into the stack. Now, if we were to push a value, oops. I was debating whether I should like try to do it blank or not, but knowing me, it's probably better that we have this right now. Do you guys have any questions so far? Does everything make sense?
Yeah. So like, because I know the problem we ran into this morning with like, because I know like Vinny commented that our implementation was kind of slow, so what would have and took up a lot of memory. So like, what would have sped that up would have been building it as a linked list, basically, so that one had to like move. This is more related to like your last slide, but so that one had to like move that shift that whole array over whenever we removed like that first value. So I think that's kind of like a direct correlation to kind of what you're talking about.
Mm-hmm.
Somewhere like where we demonstrably see how that plays out.
Yeah, I mean, myself, even with, the data, the implementations of these things, it's kind of like, it seems pretty easy, but at the same time, it's a little bit complicated. So I feel like the way we would learn this one is, for me at least, is to like try to revisit it and revisit it until it clicks, That's the way I feel about it. Okay, so now if we were to push a value into there, of course, we're going to create a new node first, because what is linked list? The linked list will have, it's a node, right, that has the value and then the next. So this is what it's doing. It's creating us a new node to put the value of our, that we wanted. And then, of course, if the length is 0, then that top equals new node. Of course, you're just gonna push into the stack, and then that new node also, because it's 0, is also going to be equivalent to the bottom. Else, if that's not the case, and I wish I have a diagram to show this, but if that's not the case, then we're gonna need to grab the last top, but the last element in the stack and make that as the top, and then you push, you get the top, then that top is gonna be emptied, right, in memory. So then you're gonna put the new node in there, and then the next, so it's kind of like this, if I can do that. Let's see. I don't know how to demonstrate this, but if we have a stack of crystal first, and then we put David goes up on top, and then we have Vinny goes up on top. So David or Vinny over here should be the top value. And then Crystal will be the bottom value. And so if we were to push into the array or into the stack, I don't know why I'm keeping saying array. If we were to push Jan in there, then we're gonna need to make Jan the top. So this top right here, we're gonna grab it because this was our old top. And then we're gonna reassign it to Jan. So Jan now is going to be the top. And then once we did that, then then the next of that node is going to be Vinny. So that's gonna be the old top. So the next pointer for this one is gonna need to point to Vinny right here. I don't know if that makes sense. And you know, just for fun, you get the length of it and then you just return this. So if we were to, let's see, implement it, if we push, let's say, David. See, the top node is going to be David. Then David has the next, which is null because he doesn't have anything yet. And then the second one is David is also going to be the bottom. And then if we put Crystal, so now we took out David with the old top and put that into Crystal. And then Crystal's next pointed to David. All right, next is pop, which is just basically removing the very top, oops, the very top portion of the stack. So if the top is, I guess, empty, then you just return null. If the top is equal to bottom, then if the top is equal to bottom, then the bottom was, this is gonna has something to do with when you actually delete the stack, and if you don't put this in, then there will be a value for the bottom. I think we're gonna see that in a second, but let's see. I don't even really understand everything right at this moment, but so when we pop the old top, that's going to be the top right now. And so if Crystal was on top, we're going to take Crystal's top next node and I guess remove it. I don't know. Does it make sense? I don't even think I'm making sense right now. Okay.
Yeah, it's okay.
I mean, I'm getting it.
Yeah.
You're getting okay,
Yeah.
good.
Yeah, I think you're good.
Okay, so when we pop, what happened? So Crystal disappeared because Crystal was on the top. So she was at the top, right? And then the next of the top, I guess we pointed it to the old top, which was David. He was the previous top. And then, so anyway, we just rearranged that. So this is what's gonna happen if we don't actually have this one right here. If we actually run and pop, let's see if we can pop another one. See, then oops. Yeah, so technically David should have been gone already, but because we didn't do this one, if top is equal to bottom, then the bottom should be null as well. That's what this code is doing. So now if we pop one more time, then everything's gone. Should be null. But anyway, I'll copy this implementation later on and the links to it. Okay, now next. Oh, so queue implementation is kind of similar. With the queue, of course, we're gonna also create a node, and then instead of the top and bottom, the queue is gonna be first and last, right? And if we pick, instead of looking at the very top, we're gonna look at that first, the first item. And then to push or enqueue a value, we're gonna need to get a new node. And if the length is 0, then you're gonna assign the new node as the first and also the last, since that's what we have. Otherwise, we're gonna put that this, that last, that next, the next node of this last to be the new node. And then this, that last is equal the new node. That's kind of like similar to what we did earlier. We're just reassigning the reference of the elements, I guess. And to DQ it, of course, if it's not the first one, then you just return null, because if there's nothing in the first, then it's obviously gonna be null. And if this, that first, that's the same thing earlier, like if we don't put that in, then we can't empty out our stack altogether. So if we run, David is our first, and then if we put Crystal in, then Crystal, David is the first one now, and then Crystal is the new one. And then if we were to remove, okay, hold on, I don't know what happens. Yeah, so if we remove, David was the first one, so David went first also. Okay, I hope that makes sense. I'm sorry. Let's see.
No, you're doing good. It's really helpful.
Okay, so now that was it. Do you have anything, any questions about the stacks and queues, or any ahas, anything?
That's really good.
Seems-
Like seeing the different implementation of like why not to use an array whenever you're doing this is actually super helpful.
Yeah, that was good.
Okay, good. All right, so now, how does JavaScript work? And the reason why I put this up is that in a few slides here, we're actually going to see a little bit of how the stack works in the JavaScript when we program. So a lot of people, you know, from what it's probably a general statement that some people do code, or a lot of people can code, and everybody can code, but doesn't really know exactly what's going on behind the system that we're using. So that's kind of like, you know, a pilot flying a plane that doesn't know how the plane fly. And so I'm just putting this in so we'll have an idea of, you know, the system what we're working. So what is a program? A program is basically, it does two things, right? It allocates memory, and that's when we do const A equals 1, const B equals 2, const C equals 3. That's how it allocates memory for us. And the second thing is like it parses and executes the scripts. So like the function, it executes it. So how does JavaScript work? So JavaScript actually have a JavaScript engine behind the scene. And for Chrome, it's called V8. And then there's also a memory heap behind the scene and the call stack. So the V8 engine is the thing that actually interprets the code that we write for the browser to read. So, you know, like Chrome can read the JavaScript program that we're using. The memory heap is the one that allocates memory. So every time we const function blah blah, it's gonna go into the memory heap. And then the call stack is going to be where you are in the program. So every time there's a code that gets run, it gets into the stack. And as we can see with the stack, whichever one, the last item would be the last out. And I can demonstrate that in right here. For example, if we have a function called constant 1 that's within the function constant 2, and then in the constant 2 logs the 4. So the way the stack, it goes into the stack is this. The first one, the system, or they read the function 1, so it goes into the stack. And then once that read, then it pops, and then it goes to the function 2. So now the function 2 is gonna be in the stack, and it, it renders for us, and then, or it executes for us, and then once that's done, it pops, and then it console logs the number 4. So so they're all just stacking. Oops, Stack Overflow. I'm missing, am I missing something? Oh, okay. Go back. No. Got distracted. Okay, so can we actually overflow the memory, the stack? Yes. And that's when you look at the function full or whatever, full, that's calling another function. So what happens then, it's that it's just gonna keep on stacking and stacking and stacking indefinitely, which is, the recursive action, recursive without the base. And so it overflows. So that's why we get an error. And then, okay, the JavaScript runtime, it's really good idea to actually take a look into this. It's a little bit more, there's a lot more to it than I can explain. So I'm just gonna give you guys the resources that I've used for this slide right here, so you'll know like all these things. All right, well, thank you for your time. I know that it's very valuable, and I really appreciate you guys for being here and always doing your code challenge. That's it. I hope that makes sense. I don't know.
Yeah, it makes sense.
Thanks, Jan.
Yeah, you're welcome.
Yeah, thanks. That was good.
Yeah, that was good. Thank you.
Thank you. All right, I'll share some of these things because it's really an interesting read, you guys.